using graphs and tables to solve linear systems. Our objective is to solve systems of equations by using graphs and tables, as well as classify systems of equations and determine the number of solutions. Who uses this? Winter sports enthusiasts can use systems of equations to compare the cost of renting snowboards. Let's start with verifying solutions of linear systems. To do so, we're going to see if this solution is, in fact, a solution to this system. And we have an xy coordinate, so we're going to substitute our xy in. So we have 2 minus 2 times 4, and we want to know if it, in fact, equals 6. So we have 2 minus 8. Well, 2 minus 8 is negative 6, so that does not equal 6. As soon as it doesn't work for 1, the answer is no. It doesn't matter if it works for the other one. For example, you have 2 times 2 plus 4, and we want to know if it equals 8. Well, we have 4 plus 4, and 8 equals 8. So it works for one, but not the other. As soon as it doesn't work for one, it automatically means the answer is no. So take a moment and pause the video and try B on your own. When you return to the video, the answer will be revealed down below. Well, it worked for the first equation, but not the second, so this one is no as well. Alright, so now let's try solving linear systems by using graphs and tables. To be able to graph, you're going to want y by itself, or so that way you can make your table. So with this one, we're going to look at our first equation here. We have this x plus y equals 4. We want to solve for y and get y by itself, since y is our output value. So if we subtract x from both sides, we have y equals negative x plus 4, and that's for the first one. And now for the second one, we have our 2y plus 4 equals x, and we want y by itself. So we have 2y equals x minus 4, and then if we divide by 2, keep in mind you divide the entire binomial by 2, so we have y equals 1/2 x minus 2. So we have one equation and two equations. So now, if we make a table of values, we have our input value of x and our output of y. So when we input 1, we get 3. If we input 2 into this first one, we end up with 2. And keep going. So then do the same thing with the next one. I would pick the same numbers, why not? So 1, 2, 3, and 4, when you insert a 1, you end up with negative 3/2. A 2, you end up with negative 1, and so on and so forth. Then, now that you have your table, you can simply plot your points. So plug in your values for each one of these into a graph. And now your answer, or your solution, is where both lines intersect. So therefore your solution should be 4, 0, the xy coordinate. So now we can check. So we have 4 plus 0 is 4, and then we have 2 times 0 is 0 plus 4, so 4 equals 4. So there's your solution. Let's try one more. So take a moment and get y by itself. When you return to the video, you'll see two equations with y on its own. So now y is by itself for both equations. You can also use your calculators to find a table and graph. So, on your graphing calculator, if you find your y equals button and you press this button, you can then input new data. So at your y values, you would have your first equation would have 3x plus 2, and your second equation would have x plus 4. And then if you want to see a table, so that way you can see your table of values, you would hit the yellow second button. So the yellow second button, and then your button that says graph. Because right above that in yellow, it says table. And when you do, you end up with something like so. Well, if you also want to see a graph, simply just hit the graph button and it will show you a graph. And then, to find where they both intersect, find where the two y values are the same. So at 1 and then 5. So 1, 5 is where the graphs intersect. Alright, so let's try classifying linear systems. So this is when we look at whether or not it has one solution, infinitely many solutions, or no possible solution at all. Well, we were noticing that each of your graphs that you drew, they intersected. They had different slopes, and when they intersect, you're going to have exactly one solution. Now, if you have infinitely many solutions, the two lines are going to be exactly the same. They have the same slope and the same y-intercept. So if you had y equals 3x plus 2, the other equation would be y equals 3x plus 2. That means every single point lines up. Well, if you have parallel lines will never intersect, so there can never be a solution, because a solution happens when they intersect. Let's practice. Alright, so let's start by getting y by itself. So we have 2x plus y equals 3. So y equals negative 2x plus 3. And then we have the other one, which is 6x equals 9 minus 3y. And we want to get y by itself. So let's start by subtracting 9. So we have 6x minus 9 equals negative 3y. And then we can divide everything by negative 3, leaving us with negative 2x plus 3 equals y. Alright, well, the slopes are the same, so it could be parallel, or you could have a system where there's infinitely many solutions. So let's look at our y-intercept. The y-intercepts are exactly the same. So it's the exact same equation. Therefore, there are infinitely many solutions. And if we look back, if it has infinitely many solutions, it's consistent and dependent. So it's consistent and dependent. Alright, so now let's look at B. Take a moment and pause the video and try this one on your own. When you return, the answer will be revealed, similar to the fashion it is above. Alright, so we have y by itself. So we have y equals negative 3x plus 3 and y equals negative 3x minus 2. Well, our slopes are the same. However, our y-intercepts are different. which means that it's not infinitely many solutions, it's no solution. Because the two lines are parallel, they'll never intersect, which makes it inconsistent. Let's try a winter sports application. Big Dog Snowboard Company charges $15 for equipment rental plus $35 per hour of snowboarding lessons. Half Pipe Snowboards Inc. charges $40 for equipment rental plus $25 per hour for lessons. For what number of hours is the cost of equipment and lessons the same for both of the companies? Alright, so let's look at our Big Dog Snowboarding Company, BDSC for short here. Okay, so we have y equals, and it's $35 per hour, and it's 15 to start. And then our Half Pipe Snowboarders Inc. Sorry, should probably put that I in there. So HPSI is y equals, and then it's $25 per hour for lessons. So $25 per hour for lessons. But you start with a $40 fee. Alright, so for what number of hours is the cost of equipment and lessons the same for each company? So let's look. Alright, so our slopes are different, so we know that we're going to at least have one solution. This is an actual plausible possibility here. If the slopes were the exact same and different y-intercepts, if they never intersected, you would never have an answer to this problem. Alright, so let's start by making a table. So we're going to make a table of values for each. So for our first one, we'll pick 1, 1.5, 2, 2.5, and 3. So when we plug those values in, you get an output of each of these. And then do the same thing with your y value, your second equation. So your y equals 25x plus 40. So you have your inputs. I would pick the same numbers for these. And then you get your outputs. Well, when are both of your outputs the same? Alright, so at 2.5, you end up with 102.5. So, $102.50. So for what number of hours? That would be 2.5 hours, because that's your X there. And the cost of equipment would be $102.50. And that ends our lesson on using graphs and tables to solve linear systems.